Okay, so we've got a new theorem.
Oh, yay.
It says a line segment that joins the midpoints of two sides of a triangle is parallel to the third side, and its length is half the length of the third side. Okay, so let's start by drawing a triangle. Any triangle. I'm going to call this triangle triangle A, B, C. I said a line segment that joins the midpoints of two sides. So if I go to the midpoint of AC and the midpoint of AB, and we connect those, then we actually get parallel lines. So if I call this point D and this point E, then notice that segment DE is parallel to segment CB. Also, and the less obvious part of this theorem, is that the length of this line right here is half the length of the other side. So the length of DE is the length of BC divided by 2. So we can use this information to find unknown information in a picture. So notice, first off, Justin, since these two segments are congruent, this point right here must be the midpoint of this whole segment. Since these two segments are congruent, this point must be the midpoint of this whole segment. Okay, so we have a triangle like this, which means to find x, this line right here will be what of this top line right here? How are these two related? It's half, right? So x plus 10 divided by 2 will equal 20. So imagine this said 20 over 1. Just play along for a second. Imagine this said 20 over 1. We would have a proportion. Now how would we solve this proportion? Cross multiply. Now notice what happens when we multiply by 1. It stays the same. But when we multiply by 2, we get 40. Which is why when we're dividing by 2, if we want to solve, we just multiply both sides by 2 essentially. Cross multiply, we get x plus 10 equals 40. So subtract 10 from both sides, and we get x equals 30. We want to find y. Now, how are these two segments that have y in them, how are they related? They equal each other because of the congruency marks. So we can write the equation 4y plus 6 equals 2y plus 16. So we're going to subtract 2y from both sides and subtract 6 from both sides. So 4y take away 2y leaves us with 2y. 6 take away 6 is 0. 2y minus 2y is 0. 16 minus 6 is 10. Now we divide both sides by 2. So we get y equals 5. Another theorem says if 3 or more parallel lines intersect 2 transversals, then the transversals are cut into proportional segments. Okay? So if 3 or more parallel lines, so I'm just going to draw 3 parallel lines.
Do we have to draw this? Yes.
Got a lot of empty space, don't you? It says they intersect 2 transversals. Okay, so I'm just going to draw, there's a transversal and there's a transversal. Now I'm going to label the points here. I'm going to call this intersection A, B, C, D, E, and F. So I'm labeling those points where they intersect. So if these 3 lines are parallel and they intersect 2 transversals, then all of these segments are actually proportional to each other. In other words, the ratio of AB to DE equals the ratio of BC to EF, and that will equal the ratio of AC to DF. So we can write our proportion using any two of those. We can also, remember, we can always, like we saw on Friday, we can replace anything that's at a diagonal. So like the ratio of DF to DE will equal the ratio of AC to AB. There's actually a lot of different proportions here that will be true. Okay. All right, so let's do an example. We use that to find the value of x. I'm going to show you, I'm just going to show you two ways. Not going to do it on Friday. Show you two different ways. There's a lot, there's potentially more, but you need to choose one for each problem. So one way we can say is, well, the ratio of 11 to x must equal the ratio of 8 to 7. Right, so I did the ratio of this to this equals the ratio of this to this. So cross multiply.
8x.
We get 77 equals 8x. Divide both sides by 8, so x is 77 over 8. And we can leave it as a fraction. Or we can write a decimal, it doesn't matter. Okay. Alternate way, well, we could say the ratio of 11 to 8 equals the ratio of x to 7. So notice the relationship here, 11 over x or 11 equals x. Right? Either way, they're corresponding. So cross multiply. And notice what we get after the first step. 7 times 11 is 77. 8 times x is 8x. It's the exact same as over there. Okay. So again, there's multiple ways to set them up. The key is for the corresponding sides go together, essentially. Example 3 says, find the value of x and y. Now notice we've got 1, 2, 3, 4 parallel lines and 2 transversals. But the same is going to apply. These segments here are going to be proportional. Now we have one pair with x's and another pair with y's. We don't want to mix the x's and y's because that won't be all that helpful. We want to solve an equation. So we need an equation with only x's and we need an equation with only y's. Okay? So 3 over 4, so this over this equals x over x plus 4. That'd be one way to do it. Oops. X over x plus 4. So we cross multiply. So we get 3 times x plus 4 equals 4x. Now again, remember you have to distribute the 3 to both terms. So we get 3x plus, and then 3 times 4 is 12 equals 4x. So subtract 3x from both sides. We get 12 equals 1x, which is the same as x equals 12. We also want y. So what's our ratio for y going to look like? There you go. So 3 over 4 equals y over 2y minus 18. Similar idea. Remember, you want only x's in one and only y's in the other. Otherwise, you'd have a really hard time solving. So we cross multiply. So we get 3 times 2y minus 18 equals 4y. So remember, we have to distribute here. So 3 times 2 gives us 6y. 3 times negative 18 gives us negative 54. I've got my larger y over here, so I'll just subtract 4y from both sides and add 54 to both sides. So 6y, take away 4y, leaves us with 2y. We added 54, so we have positive 54. And then finally, we divide both sides by 2. And so we get y equals 27. And then the last theorem is actually an extension of this theorem we just saw. It says if 3 or more parallel lines cut off congruent segments on one transversal. So if the segments now are congruent, not just proportional, but congruent, then they cut off congruent segments on every transversal. So notice what we've got. So let me move this out of the way so I can draw a picture. I'll just erase this. So if I've got 3 parallel lines, again, it says 3 or more, so it could have 4 or 5 or whatever. And we've got a transversal, and another transversal. Now let's say I know that I need one more parallel. Let me do one more parallel. Okay. Let's say I know that this is 5, and this is 5. Okay, for whatever reason, I know that. Either I'm told that or I measured it, whatever. And I know that this right here is 6. Okay, so again, either I know it or I've measured it. Then I'll label A, B, C, D, E, F, G, H. All right, so I'm just labeling my points. Notice AB is 6, right? Because these are all congruent also. So that means BC is 6 and CD is 6. Okay, so if we know that some of these are congruent, that means all of them are congruent. Okay. So length of AB is 6. So look at how that applies here. What do these tick marks mean? It means they're congruent, which means all of these must also be congruent. Now, we want to solve for x and y. So when we're trying to solve an equation, we only want x or y, not both in one equation. Okay, so do we have two equations with x in it?
Yes.
Yep, so we got this one and this one, right? So I'm going to write an equation that says, I'm going to put the 2x minus 4 first. 2x minus 4 equals x plus 2. And then to find y, I'm going to write an equation with the two y's. They must be equal as well. So 7y minus 6 equals y plus 6. And so then I solve these completely independently, one to find x, one to find y. So subtract x from both sides, add 4 to both sides. So we get x equals 6. Subtract y from both sides, add 6 to both sides. So we get 6y equals 12. Divide by 6. So y equals 2. So I'm going to give you the answers on some of these, so you can check yourself as you're going. Not all of them, because some of them are just, they give the answer, that takes away all the work. And you check them again. Okay, so number 1 is 4/3. So write this off to the side, so that way when you finish, you know you did it right. Number 2 is 8. Number 3, x is 2, and y is 12. I might need you number 4. Number 5, x is 6/7, or 6/7, and y is 3. Number 6 is 36/7. Number 7 is 75. Number 12. You'll get 2 answers. One of them is 28/3, and the second one is 79.
That's x to 80.
Mm-hmm. So x is 20/3, and 80 is 79.
20/3?
28/3. And then number 13, x is 12.
What was the x total again?
That's 9.
And 13
That's
is,
the remainder of the period to work on this.
13 is 12?
Ready for this?
13 is 12?